Today I'm going to model for you how to find the missing variable in a couple different problems. A lot of people look at this problem and might say that, well, I know this problem. I know that 7 times 3 is 21. But starting with these basic problems, we want to make sure that we know the steps needed to get that answer. So how could we get, using 21 and 3, how could we get that answer 7? So what would you do? So when we take a look at this, what we're going to be practicing doing is saying, well, I have two options. This is a multiplication problem. So that tells me that I have two options for what I might do. This is a multiplication problem. So I'm either going to multiply or divide to get my answer. So if I am going to get this answer, I want to think about, okay, I want 7 there. 7 times 3 is 21. But how would I get 7 using 21 and 3? I know that I want a smaller number here. I want 7, which is smaller than 21. So if I want a smaller number, I should be thinking, well, then I need to divide. So I would do 21 divided by 3. And I would do 3 divided by 3. Because whatever I do on this side, I have to do it on the other side as well. So 21 divided by 3, I know is 7. And I know that 3 divided by 3 is 1. But then I have to take a look. I still haven't used my equal sign, so I'm going to bring that straight down. I have not used this square, which is my variable, or the multiply sign. So I'm going to bring those down. So I'm going to bring my square down, and I'm going to bring my multiply sign down. So now we've been practicing that anything times 1 is itself. If I'd say 99 times 1, the answer is 99. If I say 2 times 1, the answer is 2. So if I say square times 1, the answer is square. So I just did square times 1 is square, because anything times 1 is itself. So then I still have my equal sign, and I still have my 7. So now I'm saying that 7 equals my variable, or the square. So to check this and make sure that I'm doing it correct, I would plug my 7 into where the variable would go. And I can do it either just right on top of here, write a 7 and check it, or I could rewrite the problem and just see if it works. A lot of times kids prefer to just write it up on top, which is fine. If I look at this now, and I look at where I put the 7, 7 times 3 is 21. And now I see that it is true, and I did get 7 for an answer by dividing by 3. Remember, you can only add, subtract, multiply, or divide using the numbers that you are given, using the two numbers that you are given. So we're going to look at another problem now where there's just one more step. In this problem right here, it gives you 7 times 8, and those two numbers are right next to each other, so that's where you need to start. So what I want you to do right now, if you're working along with me, I want you to just pause this right now, and I want you to solve 7 times 8. So I'm hoping you thought about our trick when we talk about 7 times 8, and we say 5, 6, 7, 8. So 7 times 8 is 56. So you should have written that underneath the problem. Now, we haven't used the equal sign, so we bring that straight down. We haven't used multiply. We haven't used subtract, and we haven't used the 4, so we bring that all straight down. Now this is a new problem we're working with. The one above it, we're done with that for now. So you could cross it out if you want. So we're going to move on, and now we have a subtraction problem. So if we have a subtraction problem, let's see, we have a subtraction problem, so we need to think, well, I have two choices with subtraction. In the subtraction family, we have addition and subtraction. So what am I going to need to do to get my answer? I want you to pause and think about what would you do to get your answer. Do you want the first number in a subtraction problem to be bigger or smaller than the other two numbers? I know that the first number in a subtraction problem, because we always read left to right, so we have to read this problem x minus 4, because we read left to right. So in x minus 4, the first number would go right here. And I know in subtraction problems, I need the first number to be bigger. So in order to get a bigger number, I know that I'll need to add, because when I subtract, I'd get a smaller number. So I'm going to add the two numbers I'm given. And I only have 56 and 4 for options. So I'm going to add 4. But if I add 4 on this side, I need to add 4 on the other side as well. So 56 plus 4, 6 plus 4 is 10, 5 plus 1 is 6. I bring down my equal sign. I still have my x. And we talked about, or we will talk about, that negative and a positive, they're opposites, so they cancel each other out. It's like going on a walk. If I take 4 steps backwards and then I take 4 steps forwards, I'd be back at the same spot. So this cancels each other out because they're opposite symbols, so that's like saying nothing. So now I have x equals 60. Now, the next step that's really important is checking your work. Does x really equal 60? Well, let's take a look. Now, our original problem was this, so I'm going to rewrite that. 7 times 8 equals x minus 4. I think that x is 60, but I want to check that. So I have to think about this like it's two separate problems. So I have a problem on this side, and I have a problem on this side. So I have my 7 times 8. I know that's 56. Now I think that for x, I think that I should put 60. So if I think 60 goes there, 60 minus 4 is 56. So yes, that is right, that both sides are now carrying the same value. I did balance my equation.